All right, welcome back to linear algebra. Let's jump into Anki. What is a column matrix? A column matrix is a matrix with one column. Only one column, that is. No more than one column. Well, exactly one column, I should say. Exactly one. All right, that's all for Anki. So what I'm gonna do next is grade what I did yesterday, and then actually, were we doing a proof? That is right, we were doing a proof. That is right. All right. We did have a few to grade, so I will grade what I did yesterday and then continue working on this proof. So I'll be back in a bit. All right, well, we finished the proof. I needed a little bit of help with from ChatGPT's the hint. The hint I got, so first of all, I got everything else right, but let's continue. So this proof, I'm trying to prove, right, for every square matrix A, every square matrix A can be expressed as the sum of a symmetric matrix and a skew symmetric matrix, okay? And this is the hint that the book gives. And so I knew this had to do something with it, but I couldn't figure it out for a while. And I said, well, if any square matrix A and B and C are square matrices of the same size as A, and B is symmetric, and C is a skew symmetric matrix, then all we must show to prove the statement is that A equals B plus C. Okay, and so we just list what a symmetric matrix is, skew symmetric matrix. Here's the little algebraic statement. And then what I went ahead and did was, this is the hint I got from ChatGPT, is take the formula that's given and just arbitrarily assign, hey, this term right here, that's B, this term right here is C. Cool, let's see what happens. So let B equal that, C equals that. We'll take the transpose of both sides. And I think you can then distribute that to terms over an addition problem, I believe. Then the transpose of B is just B because it's a symmetric matrix. Transpose of a skew symmetric matrix is going to be negative, right? And then I do the distributive property and get 1/2 A plus 1/2 the transpose of A minus 1/2 A plus 1/2 transpose of A. Cancel out the A terms, add the transpose of A, and then we get the A transpose equals transpose of A. So that should prove it. And then true or false question. Basically, the sum of an upper triangular matrix and a lower triangular matrix is a diagonal matrix. That's false. And here's a little counterexample. That's not a diagonal matrix. It's symmetric, not diagonal. So that's it for today. Talk to you tomorrow. See you.